If we have a complex number z equals a plus bi, then z to the power of n is just a plus bi all to the power of n. And that's just the same as multiplying a plus bi by itself n times, just like you would if the base was a real number. So if we have something like 2 plus 3i all to the power of 3, that's just equal to 2 plus 3i times 2 plus 3i times 2 plus 3i. Notice how there are 3 terms in this product since the exponent was 3. So we can multiply these complex numbers using the distributive property. So we'll start with the first 2 terms, and 2 plus 3i times 2 plus 3i is equal to 4 by doing the first multiplication 2 times 2. And 2 times 3i is equal to 6i, 3i times 2 is equal to 6i, and 3i times 3i is equal to 9i squared. And all of this is multiplied by 2 plus 3i. I squared is equal to negative 1, so we can simplify the first term and rewrite this as 4 plus 6i plus 6i minus 9 if we replace the I squared with negative 1, and this is multiplied by 2 plus 3i. We can simplify the first term further and rewrite this as negative 5 plus 12i, since 4 minus 9 is equal to negative 5 and 6i plus 6i is equal to 12i. And once again, this is multiplied by 2 plus 3i. We can apply the distributive property to multiply these complex numbers again. Negative 5 times 2 is equal to negative 10. Negative 5 times 3i is equal to negative 15i. 12i times 2 is equal to 24i. And 12i times 3i is equal to 36i squared. If we replace I squared with negative 1, this becomes negative 10 minus 15i plus 24i minus 36, and if we combine the like terms, this expression becomes negative 46 plus 9i. So this is how you do exponentiation of complex numbers where the exponent is a positive integer. You multiply the complex number by itself a set number of times depending on the exponent, and then you simplify the expression by doing the multiplication of the complex numbers. If the exponent is 0, then the expression is always equal to 1, no matter what the base is. So if the complex number z equals a plus bi, then z to the power of 0 is equal to a plus bi all to the power of 0, which equals 1 no matter what the complex number a plus bi is. This is the same as when the base is a real number, and the rule that anything to the power of 0 is equal to 1 applies to complex numbers. So if we have something like 2 plus 3i all raised to the power of 0, this entire expression is just equal to 1 since the exponent is 0. So let's say the exponent is a negative integer. Then we can make use of the formula z to the power of negative n equals 1 over z to the n to get rid of the negative exponent if n is positive. This is a law of exponents for negative exponents, and it applies when the base is a complex number. We won't consider when the exponent is non-integer for now. So if we have something like 2 plus 3i all raised to the power of negative 3, we can use the exponent law and rewrite this as 1 over 2 plus 3i all raised to the power of 3. And we already know from the previous example that 2 plus 3i to the power of 3 is equal to negative 46 plus 9i. So this is just equal to 1 over negative 46 plus 9i. To simplify this expression further, we need to multiply the fraction throughout by the complex conjugate of the denominator. So we can rewrite this as negative 46 minus 9i over negative 46 plus 9i times negative 46 minus 9i, since the complex conjugate of negative 46 plus 9i is just negative 46 minus 9i. So what we have done is multiply both the numerator and denominator by negative 46 minus 9i. So we can use the formula a plus bi times a minus bi equals a squared plus b squared to rewrite the denominator as 46 squared plus 9 squared. 46 squared plus 9 squared is equal to 2,197, so this is equal to negative 46 minus 9i over 2,197. And if we distribute the division, this is equal to negative 46 over 2,197 minus 9 over 2,197i. So this is how you compute powers with a complex space where the exponent is an integer. When the exponent is non-integer, we can't just multiply the base by itself repeatedly to find the value, and we would need to use a different method, but that requires introducing the complex plane and other things.